Hi, my name is O Grady. I'm a digital platform lead here at Yellow New Zealand. Today I'll be talking about building a serverless, event-driven digital platform. I'd like to thank everybody at Serverless Days Australia and New Zealand for giving me this great opportunity to speak in front of everybody. I hope everybody gets something out of this today. And this is just a very, very high level overview of what we've been implementing in Yellow over the last few years. So I hope this is beneficial to at least some of you out there. First topics I'd like to talk about is the initial challenges we had with serverless. The first challenge we found was that we needed to get some company buy-in. Historically and in the past, we had a ECS container platform that's been extremely stable for us and has never given us any issues in terms of outages. So we decided that we needed to do some presentations to people on a weekly basis and get people up to speed with new technologies like serverless. We also realized very quickly that we needed to change our culture and break down silos. So more specifically, our development team and our cloud team needed to come together as one, as the idea of two separate teams was just going to hold deployments and development and progress up. We needed to think of new ways of working, traditional roles would change, and fundamentally the organization would change, which was a great opportunity to redefine how our teams looked. It was also a great chance for people to upskill in serverless, and we found that people were quite eager to hear about serverless and to understand it. And when they understood the benefits of serverless, they absolutely jumped at the chance, and which was a great thing. The time and effort, unfortunately, was probably the hardest part. So the project timelines didn't change. However, the technology did. So as people were upskilling and we were running proof of concepts, the project's deliverables didn't change. So there was a tight timeline around this. So that was one of the major challenges we faced. Once we decided that serverless was indeed the direction we would like to go, we then needed to start thinking about our core technologies and architectures that we would need to focus on to deliver this. In the past, we had used Amazon for our ECS container platform with great success. We already had our team skilled in Amazon, so this seems to be the natural choice. We also did a lot of research into microservices. We ran a lot of proof of concepts around microservices. Given that we had actually a long list of monolithic approaches in the past, and the issues we faced with them around troubleshooting, around development, microservices resonated with us quite a lot. And this was another core pillar in the suite of technologies that we would use going forward. We also needed a communications mechanism, and we decided on an event-driven architecture approach to use for this communication mechanism. A lot of our microservices would need to talk to each other and is structured in a very formatted way. So we realized that from a very early stage that event-driven architecture was the way forward for us. Architecture that we finally decided on, and it seemed natural to split it into 4 different layers. Our top layer was the client layer. So this included our e-commerce platform, our self-service platform, and any third parties that we wanted to interact with. Our second layer was a very important layer, as this was our API and authorization and authentication layer. So this was the layer that we exposed to the outside world. So this, from an Amazon perspective, included technologies like API Gateway, AppSync, and deeply embedded in that was our identity management platform, which was our Cognito. This is the layer that managed interacting with clients and third parties. And this was an important layer where we initiated contact with Amazon and where all of our business logic would be triggered from. Layer 3 is where our business logic lived. This is pretty much where all of our Lambda functions were created, our step functions, any queuing mechanisms, and where we would eventually create something called search services. This is also where all of our events would live. And this is where a lot of our event-driven architecture was driven out of. Within here, this is where developers' traditional developer role would live. It was this layer that talked up to layer 2 in terms of an API integration, and then up to layer 1 in terms of our client integration. So as you can see, this is how all of our services start to tie together. Layer 4 was our destination systems. So essentially this is where our Lambda functions talk to, or in some cases our step functions. This is where our Lambda functions would interact with our CRM systems, our internal systems, any cloud services, or any billing systems. So this was a pretty complete picture of the full environment that we wanted to interact with. Our client, down to our API layer, into our business logic, and then the destination then was where we wanted to interact with. So this seemed to fit exactly what we wanted to interact with. How the high-level architecture holds together in those 4 layers. Let's get into some of the actual Amazon services that we've used. So in a very early stage, we've noticed that step functions, Lambda functions, and API gateway, when used as a combination, were very, very powerful. So let's have a look at how step functions and Lambda functions interact. So one of the main issues we had is when a Lambda function failed. For example, if the Lambda function was talking to a third-party API. A Lambda function would fail and it didn't really have the ability to rerun by itself. We noticed at an early stage that if we wrap that into a step function, we could build in some retry logic into that. And it's because of that reason we came up with 3 strategies to deal with failure across transient failures. So the first strategy was to deal with transient failures across a period of seconds or minutes. And that was a retry logic that we would just build into a Lambda function, almost our first line of defense. The second strategy dealt with system failures that would resolve within minutes, hours, or days. This was built into the step function, and the step function would have the ability to retry the Lambda function. The third then was the final strategy, where it was just a code issue or system change that meant the execution would never get completed, and this would fundamentally be a developer change. Another strategy that we decided at a very early stage was an API gateway would always initiate a step function. Now, I guess traditionally when you think about it, API gateway would always, in most people's minds, trigger a Lambda function, but we found that API gateway initiating a step function opened up many other avenues for us. With some very, very simple VTL templating, we could initiate step functions from an API gateway, which would then traditionally run your Lambda function. We also noticed that we could actually uniquely create the IDs of these Lambda step function executions. So an example where we found this very, very useful, when an event would pass through an API gateway into our backend, if there was something very unique in that event coming through, we could use that unique ID to actually name the step function. And the reason we found this useful was when interacting with third parties, we sometimes found there was duplicate events coming through our API gateway. So fundamentally, that could ultimately mean duplicate orders, 2 builds going out to the same customer. So we needed a mechanism where we had this unique execution ID. If, for example, this same event came through twice from the third party, the first step function would be created with that unique ID, and if the second step function was created, it would fail because it would also try and use that same unique ID. So this was a very, very powerful mechanism and a really, really good way for us to manage external events coming through. Again, that just highlights the power of that step function, Lambda function, and API gateway combination. So that unique execution ID was very, very powerful. Another thing that we found very, very useful was the ability for step functions to call directly into DynamoDB, Elasticsearch, Glue, etc. So pretty much a third party could interact with our API gateway and write directly into our DynamoDB without actually any business logic and Lambda functions or whatnot. And this gave us the ability to write data into our DynamoDB and our data sources at pace. This is just one example of what a successful execution of a step function can look like. At the very top, where it says start, this is where the API gateway initiates the step function and the business logic. This is a good example as it represents both how a synchronous and an asynchronous path can look like in a step function. As it passes down through the successful states, it executes various Lambda functions and what we call choices in a step function. Now, choices is business logic that lives outside of the Lambda function and actually within the step function, which I think is a really good example of how we can destruct monolithic programs. We don't necessarily need to put all of the business logic now into Lambda functions. We can extract that even more out and start layering business logic into step functions. As it passes down, each green box means it's either a successful choice or a successful Lambda function execution until it gets to the very end, where we would then consider this a successful execution. This is one of many, many, many step functions that we've created over the past year or two, and I think this is a good representation of how potentially complex they can get, but they can really get really simple as well. Seeing how a step function works and how it interacts with Lambda functions, we could understand how our business logic was now going to execute. However, we now need to think about a communications mechanism. The communications mechanism we decided on was through Cloudwatch, i.e. Cloudwatch events on an event bus. This scaffolds the mechanism to create our own events as well as process external events from third parties. The importance of the structure and consistency was crucial in the understanding of how we were going to work with this. So developers, testers, cloud engineers all understood how these events were constructed. So developers could by themselves decide the event structure that they needed to publish onto our event bus. Information in the event given to the step function and the Lambda function was crucial, and so was the context of the event. So understanding what the event meant, where it came from, and the context of this event was crucial. We decided to split these categories of events into two. Something that has happened, i.e. immutable. Immutable alludes to the fact that it can't be changed. So this is an event that has already happened. So for example, if you've got a third-party CRM system, maybe you've just created a customer and the event is published into the event bus to let anybody else know that we now have a new customer. This event has already happened. We can't do anything about it. The second type of an event is something that has to happen or should happen, i.e. the customer updates some properties or some details. This is then filtered out into the event bus, and all other waiting event rules are waiting for this event to pick the event up and then execute whatever business logic is waiting. The idea of patterns in this environment is crucial. In the next slide, we will talk a bit more about patterns, how to write custom patterns, and how to understand and how your developers understand how to write these patterns. Another mechanism we decided to put together was to record all of these events traveling through our event bus. We created a rule that picked up all events traveling through this event bus and stored them into a DynamoDB and then streamed into Elasticsearch. This gave us the ability to audit these at a later stage. This was a nice mechanism, a nice circular mechanism, which Elasticsearch presented it back up to the user plane so that the user could query it at a later stage. The next slide, I'd just like to talk very quickly about the code that we put together very generically to write these events into our event bus. Here we can see a piece of Python code which demonstrates how we would create and construct our events and write them onto the event bus. Initially we would create a bullet 3 client, and then within the program we would use the put events API to write the event into the event bus. Now the important here is the content. And as you can see, there's a very defined structure of how these events were written. The top piece of information would be the version. So is it 1.0, is it 1.1, is it 2.0? And this was a very beneficial way to upgrade the type of information that was coming through. The detail type was used as context to the event. The time was written to give some more context of when the event actually happened. So when it went into Elasticsearch, we could filter by time. The ID was a unique ID that may pass through that could be of use. The source, this was another important field. This also gave us more context as to where the event came from. So for example, if the Lambda function knew it was coming from a CRM system or a billing system, it would write the source in here and also give a context. Like if it was from a CRM system, you could have the source as crm.customerupdate. And then the detail was the payload. And the payload was what the Lambda function used to extract the business logic for. And then resources was any additional information like environment variables. So in the next example, we will show you a work example. In this next slide, I'd just like to run through an example of what all of this looks like. So if you can remember back to the architectural diagram we did previously, we had 4 layers. The top layer being the client layer. And in this slide, you'll see it's either the yellow website or an external CRM system. The second layer is our API layer, an authentication layer. So that's our API gateway. The third layer is our business logic layer. So that would be step functions, Lambda functions, and any events. And on the fourth layer, we would deal with destination systems. So in this example, you can see our CRM system speaking to our API gateway to notify Amazon that something has happened in CRM. Now this API gateway would then call a step function, which would execute a Lambda function. Now remember, we never call a Lambda function directly. We always call a step function to manage failure, and then that step function manages the execution of the Lambda function. The Lambda function then inspects the message and dips back into the CRM system if it requires more information. Once the Lambda function has all the information it requires, it then constructs the message that we've seen in the previous slide and writes it into the event bus. As you can see on the bottom, there are 3 rules written listening for events on the event bus. Now, depending on the rule, the event could trigger all or none of these events, but let's just say it triggers all. Each event rule would trigger a step function, which would then trigger a Lambda function. So you see we also applied the pattern of never calling a Lambda function directly. We call a step function, which then manages the Lambda function. That Lambda function then has the process to transform that data or event into whatever format the destination system needs. So in this example, if for example, in the CRM system a customer is created, it's published into our API gateway, the Lambda function pushes that event into the event bus. All 3 events are triggered, and all 3 Lambda functions write into their destination systems. This gives us a really flexible mechanism. This is just one of many, many examples that we've used in the past, but we found it's very, very easy to work with. If, for example, we needed to introduce a fort rule, it is very, very simple. There is no code change. It's just adding new code, new rules, new step functions, and new Lambda functions to write into that fort destination system. So now that we were happy with our architecture, we wondered how we were going to deploy everything. We had over 60 Lambda functions, around 20 to 30 step functions, many API gateway endpoints, DynamoDB databases, Elasticsearch domains. And this was just the very start. We knew we'd become into a situation where we would hit our CloudFormation resource limit. At that point, we decided to come up with an idea around domains, how to split and how to logically group this business logic together. So for example, if a group of Lambda functions interacted with our billing system, they should obviously be deployed as one unit. We also established customer domains, i.e. if there was any Lambda functions interacting with CRM systems or the CRM system was interacting with API gateway, this would all be deployed via that mechanism. In the end, we came up with 6 domains and we had 6 deployments. This seemed to work very well, and to this day, we continue to add to this as we see fit. As we all know, the unit of deployment in the CI/CD world is very, very important. But this natural separation of domains gave us a very, very good hard boundary between where everything lived. We also encouraged small code changes. So when code was released into production, we had a good track record of being able to reverse that change. We also had a very good idea of where that change was made, and we had a record of who made it. Our CI/CD system was code build and code pipeline. We found code build very, very effective to running containers. Within our previous environment, in our ECS world, we used containers for our build strategy. So this was also used. Within that, we would use some automated testing with PyTest, unit and integration testing. We also enforced some code coverage, and we also ran many security checks before this was successfully built. Another concept that we toyed with was the idea of deploying directly to production. So when a developer would create a branch and make his code change, we give them a facility to run a specific set of commands that would give them their own CloudFormation stack. They would then run and test and develop their code within that CloudFormation stack, which would give them an array of endpoints, an array of Lambda functions, DynamoDB bases, everything they needed to do to develop. Once they were happy with the code, they would then merge directly into master, which would deploy down through the environments and directly out into production. So as you can see, automated testing would be a key part of all of this, and we encourage a lot of our testers to get involved in the creation of the automated tests as well as of our developers. In the end, the developers wrote the majority of our automated tests. And again, this is just another example of how our teams would change, how our organization would change. So now we've seen the architecture. We've just run through how we deploy our code into production. So now our code is in production. The picture wouldn't be complete without talking a little bit about operations and some of the operational challenges that we faced. So one of the major issues we faced initially was how to manage failures, how to manage Lambda functions that failed. As we previously spoke about, we tried to resolve this by using step functions and wrapping step functions around our Lambda functions. We talked a little bit about our strategies. The first strategy deals with transient failures that resolves within seconds and minutes, and pretty much that's down to the Lambda function to manage a retry. The second strategy deals with system failures that resolve within minutes, hours, or days. This would be left down to the step function. So remember, this Lambda functions can only run for 15 minutes, so anything over 15 minutes would need to be passed back to the step function to manage. And then the third strategy was a code issue or a system change that meant the execution would never be completed. And this was managed by an alarm and eventually the developer bug fixing. Another challenge we faced was how to monitor a distributed system. So not like a traditional infrastructure world, we don't have servers involved, you don't have any physical infrastructure we need to monitor. How do we monitor something where we have Lambda functions talking to API gateways talking to step functions? It's quite difficult. So we needed that single pane of glass, and that was a challenge initially. Now X-Ray has presented us with some really good options in that space. One of the major things we've seen was the development teams now become a bit more ops focused. So we don't have a traditional cloud team that looks after EC2 instances or manage container platforms. That in the world of serverless has now disappeared. So you find that the developers now are closer to this failure and closer to these challenges. A lot of the developers are now sitting in the operational space, looking at alerts, understanding the alerts, and they're the guys that write the code and create the fixes for this code. So that was a challenge. And the last challenge we found was around Cloudwatch logs. They can be difficult to use. We found that initially, about 2 years ago, we needed to push those logs into a third-party aggregator and pay an additional license for that. But as the years have gone by, Cloudwatch logs have become a lot more easier to aggregate now natively in Amazon, which is really good. Over the last few years, Yellow and I have learned a lot about serverless and serverless technologies. It's told us that we need to have a think about how our team structures are set up, how our organization works, and how our business thinks. One of the three main takeaways from this I'd like to talk about now. The first one is the importance of patterns. From a very early stage, we noticed that we needed to rely on patterns to give us some order and structure, or else this would turn into a little bit of a monster. Architecture patterns and the patterns around API gateways, Lambda functions, step functions, is something that we needed to reuse over and over and over again, and we have done over the various years. This gives the ops teams a sense of understanding, as they now know what to look for in each flow and when they're troubleshooting issues. Patterns around Cloudwatch events was another important piece that we recognized early. Documenting and understanding these patterns so that cloud people and dev teams were all on the same page, and this was key. Establishing domains early. Another key takeaway from all of this was the early establishment of the domains we've already talked about. So this set out our repository structures. It set out the structures of our API gateways. For example, we could use /customer in the customer domain, /product in the product domain, /provisioning in the provisioning domain. And these in turn would execute step functions within those similar domains. Another key takeaway was to innovate where possible. The freedom of trying new technologies and experiment meant people were super engaged in what they were doing. We like to talk about new technologies and new announcements that came through from Amazon. This super excited people on a Friday meeting as well, and understanding the possibility of what they could do next week. This seemed a very, very key factor in motivating people and driving people forward and driving innovation and technology forward. I'd like to thank everyone for logging in today and taking the time out of your day just to sit down and have a listen to what we at Yellow have been working on for the last few years around serverless and serverless technologies with Amazon. It's been a great experience, and I feel like it's been these last few slides have been very, very short, and each slide could probably be a presentation in itself. But if anyone has any questions, or if anyone would like to follow up later through LinkedIn, I'll be more than happy to answer your questions wherever. So if anyone has any questions, please let me know now.